My name is Ronald Singh. I work for Digi International, and my presentation today is about modular solutions for EV charging and renewables. But to be honest, the approach of using a modular solution can be applied to almost any electronics. In this particular case, I've picked these particular markets as they're such fast-growing markets right now, and they certainly are capturing everybody's imaginations, if not the contents of their wallet. So, there's been clearly a rise in the number of EV vehicles being adopted around the world. Governments are certainly pushing, and I understand that's in the case in Finland, are making policies and tax changes and so forth to try and drive people to use more EV vehicles. And certainly there's a lot more global awareness of the pollution and environmental impacts of continuing to use fossil fuels. And at the same time, the technology's been changing, it's been evolving, been improving. I think the key thing that everybody looks for when they're considering going for an EV vehicle is how much range they can get out of it. And range anxiety, I understand, is a real thing if you own an EV. At the same time, there are quite many challenges in the market. The most obvious one is that there's a complete lack of standardization in charging infrastructure, and there's still what can be considered to be a primitive power grid that is supplying the EV charging network, and by that I mean there's still a lot of it being based on fossil fuels rather than renewables. There's still a huge opportunity though there to be gained in terms of adopting the technology, and the most obvious one is the idea that at night when you park your car and connect it up, potentially you can give energy back to the grid depending upon how much is available in the batteries. And as I said, the obvious thing, and the EU for example is spearheading this, is that the adoption and the rollout of the EV charging network should be powered almost exclusively by renewables. Of course, one of the big barriers to taking on EVs is that they are relatively more expensive than internal combustion engines, and there are certainly, depending upon the geography you're at, quite stringent rules as to how the EV charging network is rolled out. Suffice to say though, if you look at the rise in the increase in the number of EV charging stations out there, it's fairly obvious that if you look at the people who've got cars, I don't know how many people here have got them, but domestic charging on your front door is the preferred means of charging your vehicle, which if you think as the population migrates more and more to EV vehicles, it does beg the question what all the petrol companies are going to do with all their service stations, because typically most of the people using them live within 10-15 kilometers of a petrol station. There's going to be a lot of empty land there. There's only so many out-of-town visitors that are going to want to visit all those petrol stations that are in the high streets or the main roads of major cities like, for example, London. Suffice to say though, a bit like the Internet of Things, the numbers of expected units of charging deployment are looking to be exponential, and certainly we as Digi, we're very active in this area. We've got a lot of large customers around Europe, both sort of big brand names like Siemens, but also a lot of startups. There have been a lot of new entrants into this marketplace. And that's really the point I wanted to make about why a modular approach. There is a window of 10-15 years to make some real money in this marketplace, and everybody's trying to get to market quickly. You can't hope to do a chip-down design, take 2 years to get your product finished, and then go to market. You'll have missed most of the sweet spot. You need to get a product out now, get the approvals done, and hope that the aesthetics and the GUI and everything else about it is what attracts customers to buy it. Waiting to do a chip-down design, you will miss the huge window of opportunity it is. This is a place in the middle of the UK which is kind of like the poster child for the adoption of EV vehicles. But as I said, if you go back to the previous slide I showed, most charging is coming. Motorway charging for sure is a necessity, but high street, main road conurbations, urban charging, it's going to be interesting to see what the petrol companies do when we've all moved to an EV vehicle. Just looking at some touch points, obviously the market is segmented between the three types. We have the hybrid vehicle, which is probably the most popular, and then on the total electric versions, we have a choice between those which are completely plug-in and those which are also running a generator of some description, topping up the battery as it goes along. Another huge driving factor, and this never ceases to be in the news, is the global rush to reduce the amount of CO2 emissions that we have and the damage that we're doing to the planet. And I think if you look at this summer and the incredibly strange temperatures we saw, 40 degrees in the UK, which is never seen before, there's no doubt that we're doing a lot of damage to the planet, and reducing CO2 is a huge thing. But there's also a mental, psychological end-user migration to be overcome. Still, for some people, moving to electric vehicle, although they can see all the benefits in terms of running costs and environmental and so forth, it's still a big task to move away from what they know, which is a petrol or diesel-powered car. One of the biggest problems, and I highlighted it on one of my earlier slides, is the lack of standardization. As I said, we at Digi are working with many EV chargers amongst around Europe and globally as well, for that matter. Between the car manufacturers, who obviously drive a lot of the socket standard and the charging methods, as well as the way that the EV charging companies go to market, I liken this picture very much to the way the mobile phone market was about 25 years ago, when every single mobile phone had a bespoke lead on it. It's taken us 20-something years to get to a point where we've all agreed that USB-C will be the standard for new mobile phones. I hope to God it doesn't take us 20 years to standardize EV charging, but it's something to be considered, and it's certainly part of the fractious and segmented nature of the market. And then you also have the way that the electricity power is delivered to the cars, and it can be anywhere between an hour and a half to a minute or 5 minutes, depending upon the way that the electricity is delivered. So there's still a great deal of standardization required to take effect in this marketplace. And again, this begs the reason why a modular approach is a good one, because it could be that if you are scaling out a network and you're building the infrastructure, as these standardizations happen, all you'll want to do is to remove one part of the module and upgrade it to whatever the agreed standard it is, rather than ripping it all out and having to rebuild it from scratch. So I talked earlier about the lack of standardization. Still, I mentioned it earlier, is this thing called range anxiety. People get in the vehicle and they're constantly thinking about, how far I can get before I need my big charge. I'm guessing most of the people here are one of those sort of people, I know I am, who drive past the petrol station and go, no, I can get another 50 kilometers before I need to fill up. Well, it's worse from the EV guys, because there just isn't enough infrastructure in place. And then, of course, the big issue, again, is where is all this power coming from? The EU, in their last document that I read, has got a target that they would like to see a charging station every 60 kilometers across mainland Europe, but that network should be supplied 100% by renewables. So, how quickly can we get a scalable renewable program out there? And certainly the last 6 months, with the obvious events surrounding Russia and what they're doing to the supply chain of gas and oil, has highlighted the need to get more environmentally renewable energy infrastructure in place. And again, and I'll talk about this later on, it's certainly a segment that we at Digi have been heavily involved in, and we've been watching a number of customers in that area grow and expand their reach. So let's look at the sort of charging stations we've got. I've picked two here. One is quite simple e-charger that you would expect to see on a domestic premise, a sort of one that you would have outside your house. It's not particularly sophisticated. It certainly, at this point in time, doesn't do anything like allow for electricity to be pumped back into the network. But that's where we are in terms of the traditional one that Tesla will give you, or any of the other EV charger, EV vehicle companies. And then we have the sort of more intelligent e-car charger that you would see in a petrol station or a forecourt or a motorway services, that's usually linked up to some kind of e-commerce mechanism, because it's a point-of-sale terminal too. If we look at then that sort of more intelligent version, the one that has clearly more interface and more input output to it, typically there's some sort of high resolution display, there'll be some sort of credit card payment terminal, or maybe it's an RFID to some sort of loyalty scheme or payment scheme that's bespoke to the provider. There'll always have to be some sort of connectivity. If it's a remote one out in the farther regions of an unpopulated area, then it's probably got some sort of GSM connectivity. If it's one that in a big motorway services, it's probably one of many devices, and it's through a gateway or through Wi-Fi having its data aggregated to some network server. There'll be all the processing software and the management of the delivery of the electricity and the interfaces there too. There'll be some sort of environmental condition sensors because these things are out running in all temperatures and all environments. And I've even heard or seen rather an example where there's also a camera on there because it's also tracking the license plate of the car that comes up to it and linking it with a credit card payment terminal. When we look at a modular solution for this, and this is one of Digi's system on modules, we feel that having a module which caters to all those requirements, and I showed you on the previous slide, so being able to drive the LCD, having enough interface to connect up to a secure point of sale terminal, other USB or SPI interfaces to go to the other peripherals, such as a camera, enough processing power on board to run the GUI and any other application, particularly with regards to, say, the communication side of stuff, being able to support cellular communication as an add-on if it's a standard product that may be located in a more remote location, but equally well being able to have Bluetooth and local Wi-Fi on board for a campus type or services type system. So this is a sort of product that we're offering. It allows a customer to get very, very quickly to market. As I said, in this particular market, which is looking to hockey stick, has exponential growth, it's really important that you can get to market quickly, get the product approved by Shell or Eon or whoever you're trying to attract, and get them to deploy quickly. Taking 2 years, which is what it would take if you tried to do all those components individually and lay down a chip-level design and then getting that qualified while the market changes and components are made obsolete, you just miss the window of opportunity. Even faster way of doing it is if you adopt a SOM that's already populated on a single board computer. We do single board computers. We actually don't always believe that this is what customers want, so we tend to give all the Gerbers and all the schematics so that customers can design their own carrier board just by cutting and pasting what they want and eliminating the overhead and the burden and cost of the peripherals they don't need. And you still get to draw out all of those interfaces and required IOs that's needed for the application. But we do have, oh, and in addition to that, you need a very sophisticated operating system, something that's very mature, that leverages the best of the BSP provided by the chip supplier. We do them for NXP, but we also do them for ST as well. But we then take the operating, the BSP provided by the chip supplier, and we add our own IP on top. And typically, most of that is not only ease of use IP, but a lot of security. We have our TrustFence, which is our security platform, which leverages the hardware such as anti-tamper, but also software IP such as secure boot, because this is an application which will be in the future, if it's not already, prone to being hacked, either for malicious vandalism or potentially for fiscal fraud as well. But we don't just do those system on boards. We have other customers who have, for whatever reason, decided to go for a chip level design. We do the connectivity as well. So we have a range of wireless modules that operate at 2.4 gigs, supporting multiple protocols, such as Digi Mesh or Zigbee or what have you. We do long-range ones at some gigahertz level, and we also do cellular ones. The beauty of our modules is whichever frequency band or whichever protocol you pick, they have the same pin out. You pick the form factor, so you can swap in one for the other. So if you have done a chip level design, or if you've done a design with our SOM, you can lay out one socket and just plug in the relative RF module that you need for your application, whether it's a remote application or some kind of campus-based. And if it is one that's campus-based and you're using 2.4 gig or some gigahertz, we also do a range of gateways that allow you to aggregate the data and then spit it out to a server at some distance away. I talked about the renewable side of things. These same solutions that I talked about for RF are very much adopted by most of the popular brands of solar farms. We hold a huge market share across Europe, particularly across the south, Spain, France, Italy, many of those regions then feeding into North Africa. You've seen the sort of farms, you know what I'm talking about. There's the sun tracking system that moves, pans and tilts the panels so that they're always getting the best exposure to the sunlight. The connection and the management of that is typically done at 2.4 gig using our modules and then our gateways. So just focusing on this argument about modular versus component design, there's a few sort of things that I always throw up to people when I speak to customers, and they seem initially quite determined to go with a chip-down design. I always highlight, there's the opportunity cost. If you've got engineers who are buried for 2 years doing a chip-down design, is that necessarily the best use of them? Could they be doing something which is more opportunity for your company than doing a chip-level design? There's a timing advantage. Certainly in our experience, anybody offering going with a modular design gets to market first ahead of their competitors, and there's obviously an ability to get in with a higher price or a better chance of getting the volume or market share ahead of someone who takes another 2 years to get their product out. There's a technology debt. If you do your own chip level design, you own the design and all the cost that goes with supporting it for the entirety of its life cycle. So if you're producing a product that's going to be out in the market for 7, 10 more years, you're responsible when components get made obsolete or end of life. Perhaps that means replacing them, perhaps that means recertifying them. So that's what we call the technology debt. On-time NPI. I've been in the industry 20-something years, 25-something years, and I've never seen a chip-level design get out to market on time. I've seen more module-based designs meet their NPI timing. So going back to the timing advantage, certainly a modular approach is a better risk in terms of delivering on-time NPI. And then there's what I call modular design naivety. there tends to be this perception, and it is a misperception, that going with a module is more expensive than going with a chip level design. People tend to think, well, I'll do a quick bill of materials on the components, I'll look at the equivalent module, the module's maybe 20% difference, what am I paying for that 20% for? It's all these other things. And if you look at the last year, year and a half, and where we are today, in terms of the shortage of chip components, does anybody know there's a shortage of chip components? Right? Those of you who are in the procurement side know that you are paying 10, 15, 20 times factor on PPV to get those hard to find components. By moving to a modular design, you shift that problem to someone else. Right? So this naivety that a module is always more expensive than components. If you speak to people right now who are, trying to source 200-300 components for their chip level design, versus some of the customers who are buying one part of a module and have got agreement on allocation, they'll tell you that the multiple factor on PPV is something that's really painful for them. Just other things to consider. Again, if you're going to go chip down, you have to have your own hardware development resource. And, again, is the expertise in your company best employed on designing a perfect PCB, or is it better designing the full product? Likewise, on the software development side, a good module vendor will give you a fully comprehensive board support package with all the drivers built in for all the peripherals I've got on board. If you go chip down, you've got to integrate all those drivers yourself. Then you've got to think about how you're going to manufacture it, whether it's a CEM, whether you're going to let them source the components or you're going to source the components. And then there's the whole time to market operational cost that you lose in going this method. Looking at the module, the great thing about going with the module is most of the key components have all been selected for you, and they've been selected from the perspective that they already coexist, tested, it works, drivers, etc., all in place, the correct voltage rails, and supply chips to it. So they've picked out the main CPU for you. There's a security element hopefully on board. There's maybe some kind of administrative MCU that will drop the whole system into a low current mode. The memories will have been picked for you, and there'll be the ability to go up and down in a scalable manner on your DRAM and your NAND. And again, the same thing with the radios, whether it's Bluetooth, Wi-Fi, and both. Then all the ancillary components, such as the PMIC, the power, the signal chain, all picked, worked. You don't have to do any testing, any coexistence testing yourself. It's all been done. And then there's all the other components for you too. If I look at some of the modules that we make, we do one at the low end, which is based on an IMX6 UL from NXP. It's about, what's the size, Joe? 14 mils? 29 mils. 29 mils by 29 mils. There's something like 250 components on that PCB. Scale up to the larger ones, like the module based on an IMX8X. There's over 400 components on there. Right? Where's that delta between the bill of materials and the module? It's managing all those components, particularly in this environment where you can get most of your components and then you can't get hold of a PMIC, or you can't get hold of an MCA microcontroller, or you can't get hold of a particular memory or a particular crystal, and then you end up paying 5 or 6 times that to get that one component. And even then you're waiting for a delay, or you're buying it in the grey market and you're not sure how many failures may arise from picking that component. This is a sheer component count that you try to offload. And that's just the module itself. There's actually all the engineering effort that goes into picking all of those components, those key components, like the radio, like the processor. There's a lot of engineering time that goes into that, both in hardware and software. And then having made all those key selections, you then got to do your whole carrier board. By going with a module onto a smaller carrier board rather than designing a PCB yourself for a chip level design, you can remove 4 layers from your PCB and not have to worry about loads of the microvias that you would have to design in the CAD process. So there's a significant amount of engineering cost you strip out. And as I said, a good vendor of modules will give you the carrier board design, the girders, the schematics, the bill of material, so that you can cut and paste and optimize your carrier board. We like to think we offer a scalable, we work with various partners, and what we do is we offer a scalable path to customers. We allow them to get straight away to market with a single board computer, which has everything to it, including a very comprehensive, no testing required, very comprehensive board support package. You can migrate down to a module, and then there are many engineering companies that partner with that should your volume go like that, and you really feel compelled to go chip down, that will support you migrating from a module to a chip. In reality, I've never seen it done. I've got customers who are buying hundreds of thousands of modules every year. I often say, why haven't you gone chip down? They go, because our engineers are working on the next product. It's not even worth trying to cost optimize something that's already in production. There's no point. And we supply our modules guaranteed for a minimum of 10 years. In truth, we've got modules based on very old silicon. We're still shipping 20 years on. We sell a lot into the medical market, some into the military market, and a lot of the industrial markets, and they really don't want to change it. One of the biggest issues is code. They've got the code, the guy who wrote the code on that architecture, he's retired or worse, and they really don't have the ability to migrate to something else, particularly to move away from a real-time operating system to Android or to Linux. So as long as we continue to make them, they continue to buy them. So we've got modules we make for 20 years, but 10 years is our minimum life guaranteed, and we guarantee the actual product for 3 years. The great thing as well about going the modular approach and using the same platform as your software team and your hardware team are working in parallel, so because they're working on the same platform. And as I said, a good BSP from a module vendor is completely validated. All the software libraries are integrated, such as the drivers. And as I said, real parallel engineering from day one means faster time to market. Another thing to think about, if you're going to go the wireless route and you're going to put Wi-Fi and Bluetooth on board, if you're going to go chip down versus going with a module, a good module vendor should be giving you a module that's pre-certified, right? Fully compliant with the Bluetooth SIG, pre-certified for Wi-Fi. It certainly reduces the amount of wireless certification and approval type testing that you have to do by going this route. And if they do have to swap from one module to another, again, there'll be another pre-certified route. If you go chip down and you have to change that component, you've changed the whole nature of the board. And there are other things on the board that affect it, down to screws and where you've got your planes and lanes on your board. You've got to accommodate all that. And it's really, really not a cheap process managing Wi-Fi and wireless approvals, whether it's at a global level or a national level. It's an expensive process. And that's why for the likes of even Apple, who make mobile phones, they don't go chip down. They use a module on board. It's a piece of silicon from Broadcom or Broadcom with crystals around it, power management, and they're mounting that module across all of their platforms rather than going chip down. The good thing about going with the modular approach as well is there'll always be an upgrade path. In theory, your vendor will be saying to you, our roadmap is a more powerful processor, more memory, maybe a better radio, and guess what? It's all in the same footprint, or we have a migration path to go that way. There's a flexibility in there of being able to swap around from maybe going wired with just Ethernet to going to wireless in the same footprint, or taking on more memory, or reducing memory for cost purposes because you don't need it. And again, it's all about risk reduction, which is a reduction of time and cost. So as I said, really, the more platforms you've got, and I talk about, Apple, for example, are making mobile phones and using a module on that, is that there's economies of scales because they're using those modules across all of their platforms. By consolidating your demand, the more modules you're getting from the same vendor, then the better position you are to negotiate. And if you do go chip down and you're doing all the design effort yourself, you're also responsible for managing and maintaining the calibration of all the equipment you've used throughout the design process, and again, throughout the whole lifetime of the product. Talk about IoT, device security. Certainly, again, many of the customers we're talking to don't always appreciate that their product, however it's being used, may become a vulnerability spot for their end customer. So we draw their attention to the very comprehensive security infrastructure that we have in our products called Trust Sensing. As I said, we have two sets of modular offering. We do Connect Core, which is our system on module. As I said, it's actually I need to update this now. It's not just NXP. We've just launched a new family based around ST as well. And then there's XP, which, as I said, is a footprint compatible, pin-out compatible brand of modules covering sub-gigahertz, 2.4 gigahertz, and cellular technologies. But for us, SOMs, Connect Core, it's not just about the PCB, it's about the full offering that goes around it. It's about the board support package, it's about our software development tools that speed up your design and go to market. It's about the security infrastructure, it's about the APIs that we offer for connectivity to the cloud, it's about remote management platforms that we offer. It's more than just a PCB, a very well-designed PCB, highly integrated with anywhere between 200 and 400 components. It's about everything else that we wrap around the products, and the longevity, and the warranty, and the security. As I said, we offer a full migration path to go from a PCB to a SOM, and then we've got partners that help customers go chip down if they wish. We offer a range of products from the sort of low level here. Currently in production we have the IMX6UL based, which is our sort of mass market product, but going up to the IMX8 family. We have the A10 Mini, the A10 Nano, and the 8X. And then newly announced and released, you can read about it on the website, we have two new products either side of the mass market model there, an STM13 and an STM157. These will be in this production early next year. We'll have development kits for those products out almost imminently in November. XP, hopefully many of you will recognize XP. The form factor's been around for something like 15 years, instantly recognizable by the cut-off corners. That was the through-hole version, the first version that came out. Subsequent to that, we introduced a surface mount version, and then a couple of years ago, we introduced a mini surface mount version. But as I mentioned, amongst the form factors, they're all footprint compatible, but even amongst the different form factors, the pin-out's identical. So it's quite easy to migrate from a large surface mount to a micro surface mount because your pin-outs are all aligned. You don't have to do too much reworking of your original PCB design. We cater to all those technologies, all those frequency bands and those protocols. And again, for us, it's more than just the module, it's the ecosystem that we have around it. We have a full suite of software development tools. We do gateways. Again, we have APIs for cloud integration to Azure and AWS, and we have remote management platforms as well. So that was, I hope, gave you a little bit of flavor about where we see the EV market, renewables, and also why we think a modular approach, not just those markets, but medical markets and other markets, is the best way to look at things. And certainly, when I looked at the frustration and angst I've watched customers doing chip-level sourcing at the moment are going through, and the difficulty in getting components, I definitely would recommend at least having a look at a modular approach. Thank you very much for your time. I really appreciate your attention.